You know, Herb?
Yeah, Don?
Sitting here in front of the TV is good.
It's good.
But I long for the wide open spaces.
Look around, Don.
Okay.
Had enough?
Yep.
Then turn on Beakman.
Okay.
He's spacey.
Sure is.
Fact. Paleontologists, scientists who study fossils, discover more than 7 new species of dinosaurs every year. Hello.
Discover this.
I'm Beakman, and you've just broken into Beakman's World. I'm waxed. I'm buffed. My juices are flowing. Liza, the envelope, please.
Dear Beakman, how do batteries work? Ask Stephanie Roberts of Atlanta, Texas.
Batteries. What an electrifying subject. Stephanie, I got a real charge out of your question. How does a battery work? Inside this flashlight is a battery, a portable energy source, and a mini chemistry lab all in one. Let's look inside. There are lots of different kinds of batteries. Wet cells, dry cells, alkaline, lithium, but they all have the same basic parts. This zinc that makes the outer case and this carbon rod here are the 2 electrodes. And this chemical here is the electrolyte.
Electrolyte, a substance dissociates into ions, electrically conducting.
What that human sleeping pill was trying to say is the electrolyte is the chemical stuff the electrodes sit in.
Okay, Beakman. Nice audio visual, but it still doesn't tell us how a battery uses those chemicals to make electricity.
Liza, the answer is all about balance.
This looks like a job for Balance Man.
But where, oh where can he be?
It's Balance Man, strange visitor from this planet whose sole mission is to remind us that people and nature must stay in balance. He also does brakes and front end alignments. You know what I'm saying?
And I work for scale.
It's Balance Man.
Why, yes, young lady. Tell me, what are your balance requirements?
We need a brief explanation about batteries.
Oh, how about a battery of explanations about briefs?
Some other time. Now, can we talk about batteries?
On to batteries. Bogoscope ray. Here's the inside of a battery. But we want to get inside the inside of a battery. Power in. Each electrode is made of tiny particles called atoms. This atom's copper. This atom's magnesium. When we add the electrolyte chemicals, all heck breaks loose. The electrolyte reacts with the magnesium and separates it from 2 of its electrons. The magnesium electrode is negatively charged, creating a chemical imbalance. There's only one way to get things back into balance. When we make a circuit, a loop that connects the 2 electrodes, electrons flow through the wire, tending to get the electrodes back in balance again. The result of all this flowing is a loop of electricity. Well, have to run. I've got to go balance my checkbook.
Copper, magnesium, 2 different metals. let's use these as our electrodes to make our own battery. I've jerry-rigged this beautiful clock so we can test different chemicals as electrolytes. Now first, I'll need to clip these wires to our different electrodes. There's my copper, and let's get the magnesium right there. Magnesium. Time to play, dunk, and learn. Let's stick our 2 electrodes into this salt water. Our copper goes in. Then the magnesium goes in. And it's a loom! A salt battery! Electricity is happening here. Now let's try an alkali, which is also called a base. Okay, thank you, Ray.
Don't mention it.
And in goes the magnesium and the copper. Hey, another battery. Now time, get it, for an acid battery. Where am I gonna get some acid? Hey, perfect.
Hey, that's my lemonade.
Hey, it's also my electrolyte. Believe it or not, we can actually run this clock on lemon juice. The lemon contains citric acid. So when we add the metals, we've got ourselves an acid battery. Yeah. Now let's see if we can make a more powerful battery by using a more powerful acid. This is hydrochloric acid. Hey, you have some inside your stomach right now, helping you digest this morning's huevos rancheros.
Yeah, but not enough. Ew.
So, if I put these electrodes into this electrolyte, hey, I'm gonna make this flash bulb go off. Say cheese!
Cheese!
Ray! Hey, bada bing, bada bang, bada battery.
So there you have it, Stephanie Roberts of Atlanta, Texas. The positives and negatives of how a battery uses chemicals to make the electricity that keeps your toys going.
Going and going and going.
Coming up, we'll conduct a serious scientific inquiry into the wild and wet subject of density. Don't go away or you'll miss all the fun.
Beakman's World must now take a beaker break. And now, back to Beakman's World.
Get the lead out.
It's time to turbocharge your top knot. Here he is, the comptroller of the Quizzical, the CEO of the In the Know, the Tina Louise of the Hard to Please, the one, the only, the Beakman.
You yank 'em, I'll crank 'em. Hey, let's samba.
Do as I say, not as I do!
Question. Who invented roller skates? From Nicole Brewer of Modesto, California.
Answer, Joseph Merlin, a Belgian inventor, devised the roller skate around 1760.
Question, did he devise a way to stop these things?
Answer, yes. It's called a wall. Fast fact, the spotted skunk does a handstand to squirt smelly liquid at its enemies.
Question. How many muscles do you use when you speak?
Answer, 72.
72 muscles just to speak?
Wow.
It'll be a cold day in the South Pole when I believe that.
It's always a cold day in the South Pole, Don.
Oh, then I believe it.
Fast fact, a grizzly bear can run as fast as the average horse.
But take it from me, bears are a lot harder to get a saddle on. Question!
Hey, Beakman.
Yeah.
I got a letter burning a hole in my pocket for you.
Well, fire it in here, Liza.
It's from Amy Adams of Pensacola, Florida. She writes, Dear Beakman, how come a balloon filled with helium flies and a balloon filled with your own breath doesn't?
Up uplifting question, Amy. Balloons fly the way boats float. You remember, for something to float, it has to be less dense than the stuff it's floating in.
Hey, wait a minute, Beakman. Now, I may not be as science savvy as you are, but I happen to know that for a boat to float, it needs an ocean. Now, I don't see this thing floating in no ocean.
Ah, but it is in an ocean, Lester. An ocean of air. And we call that ocean of air the atmosphere. Let's visit our old friend, density.
Density just means how much a certain volume of something weighs.
Quite. This balloon, for example, it's filled with air. Lester, have one of those water balloons, please. Replay! Lester, would you hand me a water balloon, please?
This isn't as much fun.
Thank you. Now, look at these two balloons. They're the same size, but if we put them on the balance, we see that the water balloon is heavier than the balloon filled with air. Since they're the same size, that means...
The water balloon is denser than the balloon filled with air.
Bing! And we can prove Liza's right by putting the balloon filled with air in water.
It floats.
And if it's floating, that must mean...
It's less dense than the stuff it's floating in. Air is less dense than water.
Liza, high fives fail me.
But Beak, my man, you're still showing us stuff floating in water. What about stuff floating in air?
It's the same thing, Lester. For something to float in the air, it has to be less dense than the air it's floating in. Okay, let's take this balloon and this balloon. Both the same size, right? Let's put them on the balance and see which one is denser.
We put a little bit of tape on the bottom of the balloons to keep them on the scale.
Aha! The blue balloon is heavier.
And the red balloon must be filled with a gas that's lighter than the gas in the blue balloon.
But a bingo! Now, if the balloons are the same size, and one is lighter than the other, that means...
The lighter one is less dense.
Correct, my able companion. And if we know that the blue one is filled with air, which we do because I'm telling you, that means...
The red one should float in our ocean of air.
The miracle of the helium balloon.
I have a question.
Yeah?
You know those really cool, beautiful, colorful balloons that people can ride in?
You mean these?
Yeah. Are they filled with helium too?
Ah, a frequently asked question, Liza. Well, when we come back, the French brothers who invented these great balloons will drop in with the answers. So don't fly away. Watch where you are going.
No, you watch where you are going.
Oh, no. We are going to hit Beakman's roof.
Beakman's World will be back in a flash. And now, back to Beakman's World.
Make a left! No, make a right! Look out, we are going to...
Here they are. Here to explain more about how balloons fly. I'm talking about those fabulous French flyboys, direct from 1783, the Montgolfier brothers. Zut alors! You call that a landing?
Oh, I suppose you could do better.
In my sleep?
Right, in your dreams, sir.
Oh, tu es impossible.
Here they are, guys.
Okay. Une jeune fille. Enchantée, mademoiselle.
You call that kissing an hand? Enchanté, mademoiselle.
This is a science show.
We want to know about these balloons. Do they fly because they're full of helium?
Sacre bleu! Do you know how much it would cost to fill this thing with helium?
Excusez-moi. I can explain everything.
I can explain everything better. You see, ma petite chouchou, an hot air balloon fly because it is filled with a gas that is less dense than air.
What is this gas that's less dense than air?
Air!
Maybe I'm an airhead, and maybe I'm dense, but I don't follow.
Then it's time for le cool demo. Alors, how can air be less dense than air?
If it is hot air is less dense than cold air.
So, hot air floats on top of cold air. That's why they call them hot air balloon. If you try any of our experiments, make sure you do them with a grown-up and that you follow our instructions. And most important, be careful.
Vous avez besoin de papier, les ciseaux, un dé, une aiguille, une canette, un crayon avec une gomme et une lampe de table.
First, we draw a spiral on our piece of papier, like so.
When you cut along the line, you'll end up with a spiral like this, huh? What these two knuckleheads are trying to say is, make a hole in the center and press the bottom of the thimble through the hole like this. Being very careful, insert the needle pointy side up into the pencil eraser and place the spool over this part of the lamp here. Place the pointed end of the pencil into the hole in the spool. Carefully set the thimble in the spiral over the point of the needle. Then just turn on the light. Le clapper! Excusez-moi? As the bulb heats the air, the warmer air becomes less dense than the cooler air surrounding it. And the hot air begin to float up.
Excusez-moi. The rising warm air pushes on the spiral and voila! It turns.
And this balloon works the same way. We turn on the burner.
That makes the air in the balloon hot, making it less dense than the air outside the balloon. That's why we call this an hot air balloon.
The safest way to fly.
Arrivederci.
And so, Amy Adams of Pensacola, FLA, balloons you blow up don't float, because the air squeezed inside them is actually a little more dense than the air around them. But balloons filled with
Helium?
You okay, boss?
or hot air float like a boat, because the stuff inside them is less dense than the ocean of air they're floating in. Bada bing, bada bang, bada balloon.
What's the most famous helium balloon in the sky? Beakman will rise to the occasion with one hot answer after this.
Beakman's World will be back after these messages. And now, back to Beakman's World.
The most famous helium balloon in the sky is... Take a look at this baby. It's 6 stories high and holds enough helium to fill 500,000 birthday balloons.
And it's also got terrific taste in TV shows.
And speaking of TV shows, it's time for this one to float away.
Hey, we'll see you next time.
On Beakman's World.
Now, Herb.
Yes, Don.
Don't listen to Beakman.
Why not?
I'll tell you what really makes a balloon fly.
What makes a balloon fly, Don?
You blow them up
Yeah.
with anchovy breath.
My Aunt Chovy's in a zoo in Pittsburgh.
Oh, well then blow them up with Uncle Chovy breath.
Why don't you breathe on the remote and blow up the TV? So, Don, who do you like in the series?
You mean baseball's October Classic, the
Well,
World Series? Who can forget
No.
Reggie?
Actually,
or Kirk Gibson's clutch homer.
No, you
Or
see-
that other thing I can't quite remember.
Don, I'm not talking about the World Series. I'm talking about Beakman's World, the series. Who do you like in the series?
Oh, well, I like him and her and it.
Oh, well, then step up to the plate.
And play Beakman.
Hot dog here.
Fact. In your lifetime, you'll grow about 350 miles of hair on your head. Of course, I can do that before lunch. I'm Beakman, and you've just broken into Beakman's World. Greetings, crew. I've got a hankering for a tough question. Liza, deliver the letter. The sooner, the better.
You're in luck. I'm wearing my letter sweater.
Dear Beakman, how do they make underwater tunnels? Signed, Samuel Bell of Arvada, Colorado.
Ooh. A tunnel question. Wow. I dig tunnels.
Hey, we dig all your questions. And later on in the show, we'll tell you how to tunnel them in.
Tunnels are amazing and complicated feats of engineering. Yeah. All right, now, chill. But fortunately, Sammy, there is light at the end of your tunnel question. Underwater tunnels enable us to get to the other side without having to take a boat, catch a plane, build a bridge.
Or get really good at swimming.
Is it just me, or is this starting to make sense? There are 2 main ways to build a tunnel underwater. The most common way is not to build your tunnel underwater at all.
Oh, I suppose they just build it on shore and then drop it in.
That's right.
Uh-oh. Now he's making sense to me, too.
Engineers, the men and women who build underwater tunnels, first build them on land. They call this the immersed tube method. And it works like this. Workers build huge, same-size tubes on the shore. They seal the mouths of these tubes with airtight walls to keep the tubes from flooding with water. Once the tubes are prepared, a trench is cut underwater along the floor where the tunnel will eventually go. From platforms sitting on the surface of the water, the trench is dug by dragging a big shovel-like tool called a dredge through the gunk at the bottom of the water.
Then they use gravel to keep the trench from washing away.
Maestro, a little graveling music, please.
You mean this?
When the trench is ready, barges float the sealed tubes into place over the trench.
Then they sink, and you got your tunnel, right?
We'll see.
It floats! So Lester was wrong. I was so worried about him.
Because the tubes are full of air, weights have to be attached to the tubes to sink them. The tubes are then fastened together and sealed. Now, in real tunnels, divers use underwater welding equipment to do this. But I am just going to use my hands. Right. And section 2. Next, workers go inside the tunnel and remove the airtight walls. Since we don't have any workers who fit in this tunnel, I'm going to use this coat hanger. Okay, here we go. Good. And the other end. There we go. Finally, the tunnel and trench are buried.
But we're not going to bury this one, because we want you to see it.
Now, the tunnel is ready to be used. Liza, would you introduce our guest star?
Here she is, direct from the lint capital of the world. My pocket. Hillary Rodham Hamster.
Wait a minute. Hold the hamster. It is specifically stated right here in my contract, item 3, paragraph 2, codicil B, that I am to be the only rodent in this show.
My apologies, Lester. Get in the tunnel.
Well, you know these things aren't written in stone. Go ahead, Hillary. Knock yourself out.
Hillary enters here. The food is here. She's got to get across the river. But she can't swim. There's no bridge. And her boat's in the shop. Aha! There's a tunnel. Liza, please put Hillary in the tunnel.
Don't try this at home with any of your pets. Hillary is a professionally trained rodent, just like me.
Go for it, Hillary. And here she is, safe and dry. Hey, Hillary, did you remember to keep your lights on in the tunnel, huh? Hillary.
Okay, but you said there are two ways to build tunnels underwater. What's the other one?
Well, for that, we'll have to go to England.
And France.
The reason we have to go to England and France is because in 1987, they began an 8-year project building a tunnel connecting their two countries together. Since it goes under this body of water here, called the English Channel, and it's a tunnel, they call it the Chunnel. It's one of the greatest engineering miracles since the pyramids. Whoa. For one thing, instead of laying it on the floor of the English Channel, they dug out 50 feet below the bottom. This is the Tunnel Boring Machine, or TBM. The machine is about 20 feet in diameter and has a rotating head with steel teeth that cut through the rock under the English Channel. The TBM bores, which means cuts, a path through the rock. The stuff it cuts out is called muck. Curved steel pieces called shields are installed to keep the tunnel from caving in. Then they pour the concrete wall, install the lights, slap on the tiles, pave the roadbed, lay down the train tracks, put up the toll booth, and let the tokens fall where they may. Well, Sam Bell of Arvada, Colorado, you better believe that's how they make underwater tunnels.
Pilgrim.
Alan Ladd.
No.
Coming up next, we cook up a dish that'll really stick to your ribs. So put on your apron and stay glued to your set.
Beakman's World must now take a beaker break. And now, back to Beakman's World.
It's time to ignite! You're in. Here he is, the custodian of coolness, the horticulturalist of hipness, the Hager twin of all that is in, the one, the only, the Beakman!
You broach 'em, I'll poach 'em. Let's peppermint twist.
You break it, you buy it.
Question! What is the oldest living species? From Chastity Swafford of Pikeville, Tennessee.
Answer, a species of sea snail. They say that 3 times fast. Called Neopelina galatea. It is the oldest known species, checking in at 50 million years old.
Over 50 million years old. Wow. Think of all the birthday presents he got.
Yeah, and no wonder our neighbor Seymour the sea snail is such a know-it-all.
Question! How big is a molecule?
There are as many molecules in this teaspoon of water as there are teaspoons of water in the Atlantic Ocean.
That's what I thought.
Fast fact, the oldest letter in the alphabet is the letter O.
Oh, I did not know that.
Oh, yeah.
Oh, my.
Oh, brother.
Oh. You know what that music means?
We're switching to an easy listening format?
Never, Lester. It means it's time for...
Cooking with Art, where you learn how to cook up some tasty science experiments with stuff you can find right in your own kitchen. Here's your host, the always appetizing Art Byrne.
Oh, welcome to my humble commode. Achoo! Now, today, I'm going to teach you how to make your very own glue from milk.
Well, let me have some skim milk. I'll have some vinegar. An enamel or a glass saucepan. A big wooden spoon. Let me have a strainer. 2 big bowls. I'll have some water. Some measuring spoons. And some baking soda.
Experiments should be performed at home, only with adult supervision. And all appropriate safety precautions should be taken, all directions should be followed exactly, and no substitutions should be used.
First, you start by slowly heating 2 cups of skim milk. Yeah, and 6 tablespoons of vinegar in a saucepan. Then start stirring, and don't stop till I tell you. Pretty soon the milk will get lumpy because it's curdling. As soon as that happens, you've got to take the pan off of the heat and keep stirring until it stops curdling. When it's done curdling, pour it through a strainer into a bowl, like so. Lovely. The gooey stuff in our first bowl here is great, but we gotta leave it alone for now because it's time to add a 1/4 cup of water. And a teaspoon of baking soda. To our solid curds. Okay. Hey, you! Yeah? Did you stop stirring? Hey, I told you to keep stirring. That's better. Pretty soon, you's got bubbles, and then you's got glue. Hey, if you don't believe me, you can test it by pasting 2 pieces of paper together. Let it dry before you try pulling them apart. It was a slow day at a truck stop, so I I did this before. Looky. See, the paper rips before the glue unsticks. You see, what we was able to do here was to artificially sour the milk by adding the vinegar and the heat. This produced a protein called casein. When we added the water and the baking soda, it reacted with the vinegar. You all saw the bubbles, right? And made casein glue. Hey, a little help here, eh? I can hardly cook. Wooden spoon stuck to my shoe here, eh? So there you go. Another work of art. Until next time, this is Art Boyne saying... Hey, get out of my kitchen.
Oh, Art.
Coming up next, we're gonna take great pains to show you some great trains.
Beakman's World will be back in a flash. And now, back to Beakman's World.
It's time for another letter. Max and Zoe Keller from Sherman Oaks, California, right? Steam trains are really cool. How come you don't see them that much anymore, and how do they work?
Okay, let's get chugging on choo-choos. First of all, Max and Zoe, I love trains. And I love steam trains best of all. Train your eyes on this. Magnificent steam locomotives. With all that snorting and puffing, it almost seems like they're alive. And since we don't see them very often, they remind us of good times from years gone by.
Years gone by. Good times. Over the river and through the woods. Dad, you never played catch with me. Sorry, guys.
It's okay, Lester. You see, he's supplying us with one of the main things we need to power a steam locomotive.
False sentiments?
No. Tears.
Yeah! Tears are mostly water, and water is mostly what we need to make steam.
When we boil water,
Heating it to 212 degrees Fahrenheit.
it changes from a liquid to a gas we call steam. And steam has a lot of energy stored in it. See how it forces its way out of the spout? People have known about the power of steam since ancient Greece.
I think that's what they cook these fries in. Ancient Greece.
No, Lester, not that kind of Greece. He means Greece, the country.
Correct as usual, Lizola. A great Greek hero by the name of Hero created the very first steam engine in the 1st century A.D. This thing is just a tea kettle with 3 spouts. When the steam comes out of these spouts or jets, it turns Hero's engine around. Steam power.
What did Hero use this thing for?
Well, that's the trouble. We never figured out what to use it for. You're fired! But it wasn't until 1,600 years later that people finally put steam to work. They did it using one of these guys. A piston in a cylinder. Wow! Now check this out. The steam from the boiler goes through this valve here. A valve is like a door. And into this side of the cylinder, where it pushes the piston this way as far as it'll go. When that happens, this valve closes, and the valve on the other side opens. Then the steam pushes the piston back the other way. The piston goes back and forth, back and forth. And as it does, it turns this flywheel right here. Now, in a steam locomotive, steam pushes the piston back and forth in this cylinder here, pushing and pulling these rods. The rods turn the drive wheels, and that sends the train along its merry way for a peaceful ride over hill and dale. Unless, of course, someone's asleep at the switch. Ouch.
Wow! Steam trains are so neat! How come they're not still around?
Actually, they are still around. Ray? Oops, wrong chain. Steam locomotives were built as early as the 1830s, but were hardly in use at all by the 1960s. But there are dozens of beautifully restored steam railroads all over the country for you to ride on. This is the Durango-Silverton Narrow Gauge Railroad in Colorado. It's a museum on wheels. Today, passengers and freight travel mostly by diesel-electric locomotives. They're cheaper to build, cheaper to run, and they don't have to stop every few miles for water. Thanks for your letter, Max and Zoe Keller of Sherman Oaks, California. That's our crash course on the Iron Horse.
What will the train of the future look like? I'll give you a hint. It won't have any wheels. So stick around for the facts on trains and tracks.
Clickety-clack.
We'll be back.
Beakman's World will be back after these messages. And now, back to Beakman's World.
Instead of wheels, tomorrow's trains will hover on a field of magnetic energy. Remember how magnets can repel when their north poles or south poles face each other? Well, imagine a train gliding along on that exact kind of magnetic levitation. Since the train won't touch the tracks, there's very little friction to overcome, and the train can float along the track with nary a bump.
And less friction means it'll use less energy than the trains we ride today.
Speaking of energy, I'm just about out of it.
Good thing it's the end of the show. See you next time
on Beakman's World.
You know, Herb, I've been thinking.
There's trouble.
How come we don't see any trains around here?
Well, Don, it's just a guess, but I'd say it's because there are no tracks.
Sure, but I've been thinking, how come there's no tracks?
Because there's no place to go.
Yeah, but I've been thinking, how come there's no place to go?
Because Oh, just turn off, Beakman. You're starting to think up the place.
Think so?
Yeah.